Hello everyone. So yeah, this is going to be a continuation of the session we had. I think that was last week. I'm not very sure. So let me share my screen. Okay. Kristen, are you there?
Yeah, I can hear you.
Yeah, please. I can't share my screen. I don't have the permission to do
Okay.
that.
You can now.
Okay. Okay. So all right. Thank you. Let me see if I can hide this. Just leave it there like that. All right, so hello everyone once again. Sorry for that break. This is going to be a continuation of what we worked on last week. Introduction to Kubernetes. And yeah, before I get started, I got a complaint that someone was having problems with Minikube. So let me just quickly deal with that. So I am going to assume that the person trying to install that Minikube was trying to do so on Windows, because the error that I think I was sent, that is the only thing that is indicated to me. So if you want to run Minikube on your system, let's quickly do something. Installing Minikube. So if you want to run Minikube on your system, this is where I said you should come, right? And if you take your time before installing it and not just rush through it, you will see that there are like 3 different flavors, like for Linux, for macOS, for Windows. And if you follow this, can you guys hear me, please?
Yeah, we can. We can
I'm
understand.
very sorry. Yeah, I think my network kind of messed up a little bit there. So let's hope that doesn't happen again. So like I was saying, you want to use Minikube, which virtualizes everything for you, kind of. So to that, you need some kind of software on your host system for you to run, like hypervisor, then some other kind of virtualization tool. So there's the tedious way of going about it if you want to run it on Windows, which is editing your BIOS setting. I'm pretty sure if you come to Google and type how to run Minikube on Windows or how to enable hypervisor on Windows, you will get the steps on how to do that. But the easier way that I would recommend is I told us that if you are using Windows, I would advise that you install Docker, right? So once you have Docker, Docker even already provides something through their app interface, the UI graphics interface of the app, that you can enable their Kubernetes cluster, and it will give you something similar to Minikube. Although I have not used that before, So you might decide to test that out if your system doesn't seem like it can take a lot of weight or like a lot of load anyways. But the other one that I think is more common is using WSL. So you are going to activate WSL on your system, on your Windows system, Windows subsystem for Linux. So once you activate WSL and you install like Ubuntu as an app from the App Store, then you can install Minikube on that as if you are running on a Linux machine and you won't have any problem. Like you're going to use your Docker desktop and use Minikube with that. I don't want to go through the rigors of that because I feel like that will take us back. What I can do for us is I will just say that come here and put activating WSL on Windows. There are enough install Linux on Windows with WSL. This is official Microsoft documentation for going about everything. Please, documentation is your friend. Read it and try to get that up and running so that you can have like a Linux subsystem and you can install it on it. I'm pretty sure people using Mac or Linux won't have issues with Minikube start. So we are going to continue from there, from where I stopped last week now. I think last week, let's go back to my own 2 nodes cluster, right? Last week, we talked about deployments, we talked about pods, replica sets, and how they are watch loops, they are controllers, they are operators on Kubernetes that give each other tasks to do and all of that. So we did something like kubectl create deploy or deployment. You can actually call it deploy too. That's like the shorthand of deployment. It will still work. And you're going to specify the image and all of that. And I was saying towards the ending of that session that this kubectl is great for creating resources like that and like testing them in situations that you just want to like check for something, debug something. That's when you use kubectl to create resources. Usually when we are creating resources on Kubernetes, we use configuration files. So today we are going to be focusing a lot on configuration files. So let's go through one of them right now. So let me see simple deployment here. So the deployments that we created last time, we could have created it like this, right? Like we just have a YAML configuration file and have everything that we want our deployments to contain defined here. So the kind of this resource is a deployment. The metadata says that the name of the deployment is duration app. And then these labels, I didn't explain labels like last time. So it is very possible to have several deployments in your cluster, right? Labels can be a way of separating them so that you can talk or like you can work with some deployments and leave some out. So when you label it, you're able to do that. Then specification selector, define what the selectors, the deployment uses to find the pods that are related to it. So like we are going to be using that same label for the deployments to find the pods. And then this is the template that says that, okay, these are the definition, or this is the definition of what would be in this deployment, like the containers and all of that. So we go through the metadata again, and then the specification contains the containers, the name of the container, the image that you want to use for your container, the image pool policy, which says if not present. For this, you can have if not present, you can have always, you can have never. And then I'm going to say that, okay, I want to expose on this container port 8000. Like I told us last week, that the Flask application that we are working with in this introduction to Kubernetes, which is this, we are exposing it on port 8000. Hello, are you guys with me? Echo Logos, are you with me?
Yes, sir.
All right. So thank you. So now let me just show you how I'm going to do that. Now I said simple deployment. That's the configuration file that I'm going to apply now. So using kubectl apply -f simple deployment.yaml, right? So if I do this, deployment has been created, right? So let me do kubectl get deploy and pod. So I already have it running. You can see that the deployment has been deployed, and then the pod 2 has been spun up by the replica set. And as you can see here, I did not specify replica set in this configuration. I can come back to do that, but let me see what is going on with my deployment. kubectl describe pod. Let me see what's going on with the pod that was created. I can't use pod. So let me delete one of the pods. You can either say kubectl describe pod duration app whatever, or use pod and do slash like this. Both of them will work. So so it's saying that it has started the container duration container. Let's see if we can interact with our duration container using this payload request. So let me do kubectl get pod -o wide, right? So this is the pod that I created now, is running that Flask application, and I can use this cluster IP to interact with it. So let me just copy this here and paste it here. Control V, Control S, right? And I'll just run that script. The payload request script. So dot payload. Yeah, and it works. So instead of what I've just done is that instead of copying this command on my command line, I've created a script for it that automatically uses shebang to load bash and run whatever command I put there. So I can just run, I change the mode of this to be executable, and then I can just run this script and be able to interact with wherever the service is using the IP and the port, right? So that is that. And we can see that this deployment is working. Instead of going through the rigors of saying kubectl create deployment, specifying the image, we are using what do you call it now, a configuration file for that. And we have defined what we want for our deployment here. So another thing that I mentioned last week is that when we want to, this deployment is only located on our cluster, right? And it can be interacted with from the outside, like from outside the cluster, which is what we are actually trying to do. So to make this deployment a service, I can do that too with a YAML file. So I have here in my YAML file saying that, okay, I want to deploy I want to make a service resource, the metadata, the name of, under metadata, you usually have the name. So you should just have that. With time, all these things will become kind of part of you, or like you understand it, or if you don't actually even have to cram it. Usually YAML files are, you copy something you have worked on before and then you just make it what you want it to be now. So don't try to be cramming that. So after metadata comes name and all of that. Of course, with time, you know that, but like, I feel like you don't have to make it a point of action to cram it specifically. So like I was saying, this is a simple service. So the name of this service is prediction service, and then the specification is that, okay, let me use a selector. Now, this is where that label makes sense. Because you can remember that when I deployed the deployment, I said that I want to label it app duration, right? So now when I'm making a service too, I'm using that label to access those pods created by the deployment. Because now that I have labeled the pods with app of duration, the pods that will be created by this deployment, right? I can use that service to say that this YAML file to say that, okay, I'm creating a service using only those pods that have their label of app called duration, and it should be able to pick all of them for me, and then type node port. This could be node port, this could be cluster IP, this could be load balancer, like I mentioned last week. Then the ports that we want to expose for the service is a TCP port at port 8000, right? So let me just run this again. You know, like I said before, kubectl, what do you call it? Get deploy, right? I have this deployment running, kubectl get service. I can write service, I can write SVC. So you can see that I have this service running, but it's the service that I did not delete before. So let me just delete it. kubectl delete service, right? Right, bread. Okay, so kubectl get svc. Now I have only my Kubernetes cluster running as expected. So I can do kubectl apply -f simple, right, service, sorry, .yaml. What's going on? .yaml. Oh, sorry, I'm not in the right path. I think I'm in introduction. I'm supposed to be in configuration where the configuration file is. So kubectl apply -f simple service .yaml. So it's going to create that service. So kubectl get svc, and now I have a node port type of service running for prediction service, as I called it here, and I can also interact with it use inside the cluster with this IP, but I can interact with it outside the cluster using these ports for the node. So like if I want to interact with it with my control plane node, I can use the public IP of this node. If I want to interact with it with my worker node, I can use the public IP of this. So let me just quickly come here and do something. I don't think I want to really waste time on that. I think I experimented with that the last time. So if I can click this, and this is the public IP address. So I can copy this, open a terminal on my local system, and come and try to edit this payload request with that particular public IP of that node on AWS, and the port that it says that is exposing it for me. I did this last week, but I'm just going to do it again. Right, and then I can just copy this O command and come and run it on my local PC. And I still have my duration app predicting fine. So that's just showing us how a service works, and how instead of using kubectl expose deployments to make a service, you can actually still use a YAML file for that. Now, going forward, I think the next thing that I should talk about are some other things that you can do with a deployment. So there are some other things that come with a deployment. With a deployment now, I can specify the replica set here. I can just say that instead of doing scale, I can specify replica set here, replicas, and say that I want 3 replicas, right? So I said I was going to do that with the simple deployment. So let me do kubectl get svc. Let me delete that. Delete svc prediction service, right? I don't need it again for now. And then kubectl delete. Let me just get it again. Get deploy. So kubectl delete deploy duration app, right? And now that is deleted. So let me create this now that has replicas defined there, that I want 3 replicas. And I think I said what replicas is last week, that it is just a way of making sure that we have 3 pods running. Replica set will make sure that its particular number of pods are running on the cluster, right? So let me do a kubectl apply again. Apply -f simple service, simple deployment.yaml. I wrote rubbish in kubectl. So kubectl. So kubectl get pods. You can see now that I am having three pods running instead of one, because I have specified that I want 3 pods running. One is still trying to create. Watch kubectl get pods. Okay. Still trying to create. I don't know why it's taking time. But the point is that now that I have made it, I've added a replica set configuration to it, it's going to try to make sure that 3 pods are running so that I can have 3 pods that can answer a client's request. And this is actually where a service makes sense, because with this now, I have 3 pods running with 3 different IP addresses, but a service is going to unify them into a single IP. So like with a service, if I deploy it as a service, even if I call it a cluster IP, it is going to give all of these pods a single IP, so that whichever one of them is running is what this one that is doing container creating now. If I try to interact with it with these pods through a service after deploying them as a service on my cluster, it's not going to direct traffic here. It will direct traffic to the ones that are running, and that's one thing that service does for us. And we can do it through this node port too, that it will be available outside the cluster, or through a load balancer, so that we can have several nodes working together too. So I don't know if what I've been trying to explain is something we understand, but like I'm just going to go on now. We have quite a number of things to cover. kubectl get pods. Let me actually see what's wrong with that. kubectl describe pod. This pod. I want to see what's going on with it. Oh, it's still trying to pull the image. Okay. Well, I don't know why it's taking forever in pulling the image. Probably because some resources are getting limited. I'm not very sure about that. So let's go on. That is working with replica sets, and I can actually still deploy that service again, but I don't want to go through that same thing. Let's go to another thing. Right now we can also actually work with config maps too. So what are config maps, right? Config maps are a way of adding information into our container after it has started running, right? So we can use config maps to add some things like credentials, the name of maybe a Postgres database or anything like that. Whatever it is we are working on in our pod, we can use a config map to add it, like database username, database password. For example, now in this, what do you call it? Let's go to our app. This is the predictors.py app. And in this app now, we are saying that we have an environmental variable, right? Database username, database password. And we are displaying, this is not going to be the situation. I am just using this as an explanation, right? Usually maybe this database username and database password will be used with psycopg or what do they call it now? SQL Alchemy to connect to like a database somewhere using the app. There are so many scenarios for this. I am just trying to show us that I can use config maps to change these values, right? Right now, I'm saying that this code is saying that os.environment.get this database username from the environment if it is set. If it is not set, it will call it Postgres. This one is saying that you should get it, you should get the password if it is set in the environment. If it's not set, you should call the password. So, and then I'm using this HTML to display it at the root directory of our app. So what I've been doing since is I have been just working with this endpoint, the predict endpoint, sending a post request to get a prediction like I do with this payload request here. But I want us to actually just see the work of a config map on, for example, say the UI or something like that. It's not like an actual UI, but I think we get what I am trying to say. So let me just do that now so that it will be much more clearer. So I think let me create a service. Let me see what I have now. kubectl get svc. Okay, kubectl get deploy. Right. Okay, so I have 3 of 3 now. All of them are running, so that's good. kubectl get pods. Actually, I don't think so. All of them are actually running. So yeah, now I can make that deployment a service, right? So that I can access it on my local machine. Because what I want to do is I want to come to this place and just go to the home page of that app on my web browser. So to do that, I am going to make that deployment a service. So let me look for that simple service configuration file again, and then kubectl apply -f service abi simple service.yaml. So now that service has been created, and kubectl gets svc -o wide, not -0, -o. Yeah, so this the prediction service is running on this port for that local machine. So I'm just going to use this. Where is that? Not creating pod. So I'm trying to show us a config map, right? So this is the port that I'm going to access this in. Of course, my cluster, my public IP for my node on AWS is actually not going to change. It's still the same thing. So just the port that has changed now, because I created 2 different services. I mean, I deleted that one, and the node port has changed now. I hope I'm not speaking to myself and some people are following me. So let me just copy this command now and try to come and access it on my local machine. Yeah, it's working. So I can come here and put the IP. I'm coming. There's the IP. So as you can see here, this is what I was talking about. Welcome to the home page for the taxi ride duration prediction. And now we have Postgres here and we have password here, right? So one thing I'm going to do now is we are going to use a config map to see how I can change this. Let's go back to the control plane. And I think I have deployment with config map here. So now the way it works is that you need to create a config map. A config map can be created from literal. It can be created from directory, and it can be created from a file, right? So this config map right now, I'm creating it using a YAML file, right? So it makes it easy. This is supposed to be like some kind of kubectl create config map from literal, right? And because before you can use the config map, you have to create it, right? That's why I'm trying to create the config map first. So I'm coming. Please give me a second. So kubectl create config map. The name of the config map actually has to come before the from literal. So let's call this, like I have our config. I'm just trying to show us that we can. I'm not going to run this code, but this is how you create this probably from the command line. Kubectl create config map, the name of the config from literal, right? And then I'm just going to do an equal to for the literal that I want to have in the config map. So in this case, it's going to be what they call it, database password. Yeah, database password equal to Kubernetes is fun. I think we get what I'm trying to say. So this is how you create it from literal. You can create it from file. You can create it from directory. I'm not going to go into the nitty-gritties of that. I just want us to get an idea of what a config map is and how it works. So now I'm just going to do an apply for myself since I already have the configuration file here. So config map. So config map has been created. Let me do kubectl get cm, which is config maps. So right now I have our config. I have a number of other config maps that I have worked with, but this is the one that we are interested in, our config that I have created now. So I can use this config map now in that deployment to make changes so that in case something I want to change a parameter, or like say we already have our stuff deployed, our app deployed, I want to change a particular parameter because of whatever things that is happening, we can use the config map to do that. So this is the deployment config map, and it's still similar to what we have before. We have all the kind deployment metadata, specifying the labels, the specification, specifying, here is where we specify the replica set if we want to, the template that will point to the what do you call it now, the labels again, and the specification of the containers that will be running in the pod for this deployment. So the name of the container, the image pool policies always, I can call this if not present, right? That if it should only pull the image if it is not present, then port container readiness probe. I'm going to talk about this after config maps. So, and there are two ways to attach a config map. I know this is a lot, but I expect us to probably watch this video again at some later time. So for a config map now, it can be attached as an environmental variable, or it can be attached as a volume. So I'm still going to talk about a volume today too. Volumes are a way of persisting storage, because if you can remember that I said last week that our containers will die. So if the containers die and they are working with some particular files or some particular text or whatever, when they die, does that mean that the process will come to an end? What is the whole point of then spinning up another pod or container to take its place when we can't pick up from where it stopped? And that's where volumes come into play. You attach a volume to a container in such a way that it is persisting the files it's working on that volume. And if it dies, the volume doesn't die, because the volume has at least the life expectancy of a pod, but usually more than a pod. Containers are the ones that die. Pod are the ones that will respin the containers based on the specification of the replica set. I think everything I am saying is connecting, and it should. I'm going to try to work on volumes too. So now we are still working with config maps, and I'm saying that this config map will be used with an environmental variable here. So now I'm saying that, okay, the name of the environmental variable is database username, and the value from is a config map reference. So I'm going to reference the config map that I just created now, our config that is here, and then the key is database username, right? And then the name again, I want another environmental variable is database password, value from config map. The name is our config, same thing, but the key now is database password. And this is the restart policy for, what do you call it, when we have problems with our containers. So let me just apply that now. Let me see what I have. kubectl get pods. Okay, I think I have all of these. So let me just kubectl delete. kubectl delete SVC. I wanted to do something before, but I don't think I've spoken about it yet. So let me just do kubectl get SVC, right? Delete it. kubectl delete SVC prediction service, right? kubectl delete deployment. I think that is duration app. kubectl delete deploy duration app. Supposed to be deploy. Yeah. So now that I've deleted that, I can use this new deployment that has a config map to expose my service, and we will see how that works. So kubectl, and as you can see, I'm still specifying the same image. so that you guys will know that it's the same thing. It's the config map that is changing it. So kubectl apply -f. What is this called? I'm calling this deployment with config map, right? So deployment with config map.yaml. So this has been created. So kubectl apply -f service -f simple service.yaml. Yeah, so I have that as a service again. kubectl get svc -o wide, and I have this port now. So I can just copy this, Ctrl+C, come here and change that port to fit my new service. And as you can see, these are the values I specified in the config map. Ekwe, are you with me?
Yes, I'm here.
Thank you. So now these are the values I specified in the config map, and now they are showing up at on my own page as opposed to what I had before. So that's how you use config map. The other one, usually, you can't do this with. This is not safe because I'm saying my password is Kubernetes is fun, and I'm using a config map that everybody can see to load it into my container, and that's not very safe. The safer way to do this will be to probably just leave database username in the config map, but create a secret. So like a config map, we have a secret. And the difference is that a secret is encoded. So you can't read what credentials or whatever it is I put in a secret. I'm not going to really talk about secrets because secret is more in the region of considering security for our apps that we are deploying on Kubernetes. So, but like just know that there's a secret and there's a config map and they are very similar. So like I mentioned before, we are also going to work with a volume. And I want to mention something that till now, what we've been doing is we have been, what do you call it now? Okay. We have been deploying a single container in a pod. If you have noticed, if I do kubectl get pods now, you will see that it's saying 1 of 1, right? This means that we have one container in this pod, right? I don't know if you understand what I'm saying. We have one container running in this pod. So instead of that, we can have 2 containers. Now, when we are talking about separating a monolithic application that is like self-serving and standalone into microservices that will be working with each other so that we can achieve scalability and all of those things, it is best to have one container in one pod. But usually you might have some other things that you want to do with that main container that is not included in the main container. And an example is that maybe you deploy an application and you want to add a feature to it, and you have several versions of the application running on your cluster, right? And you want to add a feature to it, but you don't want to change the code, because what that will entail is that you will come to Flask application, come and edit your code, add some more code for, like, let's say you want to do login, for example. You add some more code and deploy that. Instead of doing that, you can have a tool do that for you. We have monitoring tools like Prometheus, FluentD. So now you can have a tool like FluentD come and monitor your application for you, and you would have it as a sidecar. So those are the situations that we have more than one container running in the pod. So in this situation now, we have only one container. I can work. Let's see what happens when we have 2 containers, because I want to use it to show us the concept of volumes. So now here you will see that we have the same type of deployment, but we have me using FluentD as the logger for it. So the usual 3 scenarios that you have another container with your main container in a pod, right, is if you want to have a sidecar, like something that is going to do login for you, and login is not already integrated in your own application, or you can have an adapter, something that will change how. I feel like I'm going into the nitty-gritties of that. Just you guys can just go and read on it. You can have a sidecar, you can have an adapter, and you can have what they call it now. There's one third one, but it's not important because it's not like you are going to specify in the configuration file that this other container I'm adding is a sidecar, is an adapter, or is an ambassador, which is the last one. But I'm just telling you the scenarios that they come into play. In this case, in this scenario, this other container is going to be the one performing login for me, although we're not even going to do that. And let me come back to what I wanted to explain initially, volumes with this. So now I have explained that I have two containers. One is my main application. One is the logger. So now I have, sorry, not including this. This is the logger. This is the main application. So the way volumes work, let me quickly come here. The way volumes work is that we have a pod, right? And we have the main app and we have like the logger here. And then you are going to attach a volume. Like I explained to us initially at the very beginning of this entire session, I said that pod is the smallest abstraction on Kubernetes, but on a pod, we can have multiple containers running. But every other thing that is applied to a pod is the same for everything running on that pod. So if we have a cluster IP, for example, this now, for this pod, this cluster IP is the same for main app, as you can see this arrow pointing to it, and it's the same for this logger. So is the case for a volume. If we have a volume attached to this particular pod, right, that volume will be available, can be made available to both the main app container and the logger container. I don't want us to get confused. This is the volume now, for example. So let me do something and let me go and create a volume on my own cluster. kubectl get persistence volume PV. Okay, kubectl get PVC, kubectl delete PVC. I'm coming. I just want to delete these resources because we are still going to create them. PV persistent volume models PV volume. So yeah, now let me just do kubectl get persistent volume again. And what I have here is just some volumes that I created at some point for some other thing. And now I want to create a volume. Okay, now let me come to the fact that we have different types of volumes. So we can have an empty directory volume, we can have a host path volume, and we can have volumes that attach through persistent volume claims, right? Now, let me explain that to us. A persistent volume is a resource that will specify that this is the type of storage that we are making available. And you can even specify the size of the volume in the volume definition, right? In the volume for configuration file. We are still going to talk about that. This is a volume configuration file. I will come and talk about that later. And then when you create that volume as a service, as you can see here, I did kubectl get persistent volumes. These are some volumes. They have been created. The capacity of this pvol volume 1 now is 1 gigabyte. This is 100 megabytes. The access mode, the reclaim policy, and all of that are the things particular to that volume. When we have this volume on the cluster, that doesn't mean that any application is using this volume or this storage, right? The way that a storage can use it is through persistent volume claims, but that also depends on the type of the volume, right? If you are using host path now, if you are using what do you call it, empty directory, you don't need a persistent volume claim for that. But like if you are using NFS, if you're using some other, maybe you're using the provision from Azure storage disk, you're using the provision from GCP or like AWS, whatever, then you need a persistent volume claim that will determine how that volume will be connected to the application. So in this case now, I just want us to experiment with an empty directory type of volume. So let's go back to that deployment with, what do you call it now? Sidecar. So like I said, we have the main app, we have the app login stuff that the main app is doing. And then I'm specifying that there's a volume here that we want to use in our pod called sidecar volume. and it is of type empty directory, right? And that's all we need. When we do that, I will now, excuse me, please. I will now go and mount this volume, because here, as you can see, this volume definition is going to be at the same level as container under the specification for the deployment. So these deployments now, we have under the specification saying that these are the containers that we want, and these containers have access to these volumes. This is the only volume I am creating in this situation, and I am now going to mount this volume on each one of those containers. So we have volume mount, and what that's going to do is that, what's the name of the volume that you want to mount? It's sidecar volume. So this must match the volume name below, actually. So this volume mount name here must match this volume name here. And then the mount part, that is, which part of your container do you want to mount this volume? So right here, I'm saying that, like, okay, let me quickly show you something. This is my host machine, right? Not any, this is like my host machine. Let me just go to the root directory. You can see here, if I do a ls in my root directory, you have temp, you have, I think, etc, you have dev, all of these other directories. These are the directories that come with typical Linux systems, right? And as you can see, in this, our application, I am starting from this image. This image is a Linux system. This fd logger2 is a Linux system. So I am basically saying that when this container starts as its own small scale machine, I want to mount this volume in paragraph for the temp or the mount, right? In this one now, for the fluentd, I am mounting it in the etc, in the etc directory. And for the main app, I am mounting it in the mount mnt directory. Remember, these two are different containers, but they are working on the same pod. So I think I have done enough explanation of this configuration file. Let me just apply it and we'll see. kubectl get deploy. I think I deleted it. Okay, not yet. kubectl describe deploy duration now. kubectl deploy duration up. Okay, I hope there's no service. kubectl get svc. Let me delete that too. Delete svc. Okay, so now let me work with this sidecar now. So kubectl apply -f deployment with sidecar. Oh, sorry, I am not where I'm supposed to be. Change directory, introduction to Kubernetes, change directory, configuration files. So kubectl apply -f for deployment with sidecar. Right. But yeah, like I said, this is an empty directory volume. So I don't need to create a volume separately for this, or create what they call this now, a persistent volume claim for this. And why? It is because this empty directory type of volume will just create that directory in the container, like where I am mounting them. And that particular directory will be available to both of them. But one thing about this type of volume is that once these containers die, this directory too will get emptied, right? So this is not the ideal thing that is used. The use case for this is if I am doing, like I said now, I just want this other container to help my main container. So I don't need to persist whatever it is they are doing into some extra storage, like maybe Google storage or AWS storage or whatever. I just want to make sure that what this guy is doing, this guy can see it. So I'm just creating a temporary directory that will still die with them, but makes both of them interact with each other. So that's what this empty directory is going to do. And let me just apply that. So kubectl get pods. As you can see now, we are having /2 for the first time because now we are running two containers in a single pod. So let's see when both of them, yeah, now they are running kubectl describe pod. You see that I use describe a lot. It's just to make sure that everything is working in the resource as you expect it to, and as it has told me now that I have duration container started, fluentd, which is the FD logger, also started. So one thing I am going to do, I think I don't know if I have done that, if I did that last week, I can go into these containers that are running. For example, now I said kubectl get pods, right? And I have this pod running now. I can go and execute a command on the command line of these containers that are running. So let me just do something. kubectl execute, and the command for that is kubectl execute. I think I have it here. Let me just copy this. So I want to go and execute a command in these containers that are running, right? kubectl execute in. Let me explain the command to us. Execute -it, meaning that you want to execute this command in an interactive mode, right? So that you'll be able to run a command inside this. Because now, you know, this kubectl execute itself is a command that I'm running on my own command line. I'm now saying that I want to execute a command in this container running in a pod, right? So now, -it, the name of the pod. What's the name of the pod here? The name of the pod is duration app, whatever like that. The name of the container, because now that we have two containers running, I need to specify the name of the container I want to execute that command in. So I do -c to specify the name of the container, and I can, let me go and look for the name of the container here, deployment with sidecar. What did I call it? Let me come and look at this fluentd, right? I called it FD logger. So the container is FD logger, and the command that I want to execute will come after these two dashes inside that container. So inside these two dashes, I am going to be running ls -l. Where did I mount this thing? At C. So let me do ls -l at C. Right now, you guys can see what we have on ls -l at C for my FD logger container in this pod. What we have in this particular pod is this. Let me show you something. What I did just now is that I am executing this command inside that container, but I can actually just enter the container itself by running bin bash. Start container execute bin bash. Bash, no such file or directory. Okay. Coming. Okay, I guess it doesn't have bash installed. I was thinking this FD logger has bash installed, but it doesn't. But let's just go back to the point of what I'm trying to make, that I have run this command, this ls -l at C. It is the same way I am running if I run ls -l root at C on my own node here on the control plane. And these are all the files I have in my etc file on the control plane. So now I'm trying to run this same command in the FD logger container. That's why I ran this ls -l at C, and it is telling me that I have host name, host, resolve conf, right, inside it. So like I said, this is the FD logger. I just want us to pay attention. I am going to create a file using execution, this same execution command inside my main app, and you will see that it is going to still be seen in this app. So let me just do that. That's what I want to do, so that you will see the concept of volumes being made available to two containers at the same time. So kubectl, instead of typing it and wasting time, let me just come and copy this and use what I'm supposed to use. Let me do kubectl get pods first, and then copy this command, paste it here, and as you can see now, the command that I'm executing has changed. You can see now that I'm doing kubectl execute inside that pod, inside the container. Touch is a, I think we should know what touch does. Touch will create a file. So touch creates this file inside this mount path, create log file.txt. So where's the mount path? the mount path for my main container. Like I said, I want to create this file in my main container. So where's the sidecar? The name, the mount path for my main container is, let me see, where's that? Mount path is mount, right? So I'm just going to put mount here. That I'm creating log file.txt inside mount in my main container. And what's the name of the container itself? I think the name of the container is duration app. I'm not very sure. Duration container, actually. So let me just copy and paste it. So duration container, what's the name of the pod? The name of the pod is this pod. So now I have created this file inside my main container, right? Let me now go and do a check on that sidecar container again and see. Before, I'm pretty sure we know that this log file.txt file was not there. But now, if I do this, you're going to see log file.txt inside that container. So that means that I am using this particular volume to have a common directory for these two containers running inside that pod, right? I hope you guys understand what I'm trying to explain. Ekwe, are you following? And are you understand what I'm trying to explain? All right, thank you for the thumbs up. So let's go ahead and talk about what they call this now, the volumes that need persistent volume claims. So like I said now, we have worked with empty directory, which doesn't need a persistent volume claim, and that is because of how it works. Like I explained to us, it's still going to die with these containers. But like say we actually need a volume that we want to persist some kind of files, we need to create both a volume resource on our cluster and a volume claim that those apps that need this volume are going to be using. So now to create a volume, you just say that it's of kind persistent volume. The metadata is that the name of this persistent volume is models PV volume. That's what I'm deciding to call my own. And this storage class tutu can be arbitrary to what you want, and you can use it to separate different volumes. So like it will be like a label of some sort. So like I'm calling my own ride prediction volume, so that when I want to use my persistent volume claim, I can specify that too, and it will just come and use this volume directly. Because the way persistent volume claim gets used is that based on the access mode and the capacity that you have specified in the persistent volume claim is how they are going to select a volume, right? So if you don't have this specified in a volume and you have several volumes of different types that have this type of capacity and read write, you are leaving it to Kubernetes to pick the volume that it wants. But if you want one particular volume to be used when a particular persistent volume claim is used, it's good to probably use this kind of label of some sort, storage class name, to access that volume. So now the capacity we want is 200 megabytes, read writes many. That is, we want many nodes to be able to read from this volume. And the type of volume that we're using is network file storage. And the way network file storage works is that usually, if you save something on this node, like I told us now, I am working with two nodes, right? This is one node and this is another node. So just like the concept of what I explained now as an empty directory, that's what the NFS is, network file storage. So what this NFS does is that it's going to connect a main node to all other nodes that you want to connect it in by running a command, right? So the NFS will make sure that whatever is saved in this path in the main node will be available to all other nodes. Remember that I am talking about the nodes now, not containers. When I was talking about containers, we were using empty directory to just see how volumes work. But I'm telling us now that in Kubernetes, if we want a situation that we want several containers to be able to read from and write, to read from, most importantly, a directory or from a volume. And we are creating the volume from this host path to make from this host machine, to make that volume available to all other machines, we need to use a network file storage. So that's what a network file storage is. You can read more about that. I know I'm mentioning a lot of things, but you just try to pick the things that you feel like you need to start and experiment and just have fun with this from there. So right now, I'm making sure that I'm using an NFS that can connect all my nodes, so that whatever it is I do on this node will also be available for me on this node. I have not done anything with the volume yet. I'm just saying that, okay, that's the type of volume that I am using here. And it's a retain kind of reclaim policy. That is when when the container dies and another one is trying to claim this particular container, it's going to retain whatever it is in that volume. It's not going to delete it or start afresh. It's retaining it, which is the point of using the volume in the first place. The access mode is read-write many. That is, many nodes that we are making this particular path available to through NFS can read and write to this particular volume. And the capacity is 200. I think I already mentioned that. So let me kubectl get persistent volumes. Kubectl I think I created some pods now or something. So let me delete that deployment actually. Get deploy. Kubectl delete deploy duration app. What's the time? Oh, it's already 1. Wow. Okay, so let me just finish this volume thing and then you guys can ask questions. Okay, so now let me create that volume. kubectl apply -f. Like I have specified here, I'm going to be using volume. I called it the name of the file volume. You can call it whatever it is you want, right? So far it ends in .yaml because that's the type of the file that Kubernetes uses. You can actually use JSON too, but YAML files are more used. So now it's telling me that persistent volume models PV volume has been created, and then let me create a persistent volume claim. kubectl creates -f pvc.yaml. So now the claim for that particular volume has been created. Now, like I explained before, this is the volume, this is the persistent volume claim. You guys can go and check it out. I'm using the storage class to make sure that I'm using that same volume that I used the other time, like I explained. And the one thing that I actually need us to note again is that the access modes of the persistent volume claim and the volume that you're defining should be the same thing. If they're not the same thing, they are not going to get bounded, because if I do kubectl get PV now, you can see here that it is bound, and it is saying that this volume has been bound to a persistent volume claim, this claim. So let me just try to create that particular deployment with volume now. So in this particular one, I'm creating a deployment, and instead of using the volumes of empty directory now, you can see here that instead of that empty directory that I had before, I'm using a persistent volume claim type of volume. And the claim name is the modem volume claim that I have here. Let me do that. kubectl get PVC. So I have modem volume claim here. Sorry, here. And then, yeah, it's going to mount this to this particular app, our duration prediction app, inside mount. So let me just kubectl apply -f deployment with what they call this now, volume. So let me just watch kubectl get percent volume. No, that's not what I want to watch. kubectl get pod. So now it's going to create that particular container for me, the application mounting the volume that I created, right? And it's so painful that time has gone, because I wanted us to talk about rollouts and all of that too. But yeah, and this is running now. one thing that I have done here that I will just explain and give you guys like some kind of, I don't know, assignment if you are curious enough to go and find out, is that I am using version 2 here, right? And one thing that this is not version 1. Usually we've been using version 1. So this is like a version 2 of that particular application. Let me create another bash and open up the space to questions if you guys have any anyways. I mean, it's only a query that is there. If he has any. So if you come to Introduction to Kubernetes, Git branch, right? You will see this Flask app version 2. So if you do a Git checkout, Flask app version 2, you're going to undo now that I am in that version 2 branch. If you come and check this predict.py file, you will see that here I am loading my binary file from a volume. So I'm loading it from mount. So this is very useful in a situation that we already have a pipeline for training several models. Of course, it's not just one model that we'll put into production. And maybe you want to be able to change the model that you are using in production. The best way could be that you just be putting that model in a volume and the container will just load the new model from that volume and be able to predict with it. Since you are saying that, okay, you have improved it, you have optimized it on accuracy and all of that, you put it in the volume, and then you can load that model from the volume here, right? And if it's not able to find it, I'm saying that you should do a model not found, can't make predictions. I think this is not correct, but like, I think you get what I'm trying to do. And yeah, if this volume was not connected, it will not be able to make predictions. But so far you connect that volume that contains that particular model, it's going to work. So that's what I just worked on now. And yeah, I think that would be the end of today's session. I was going to talk about probes and all of that too, but like, I want you guys to ask your questions, and if there's still a few more times to spare, I'll talk about probes. I'll just talk about them. I'll not experiment with them. So do you guys have questions?
No, I don't have a question for now. I think that I will need to practice a bit first before coming have some question.
You said you need to go and what?
I need to practice a bit before.
Okay. Yeah, so I think you can see that Kubernetes can be very powerful actually, because they have made possible all the ingredients or tools that you need to combine several things to make your microservices work at scale. Because this is just supposed to be introduction to Kubernetes. I don't think you guys are so much expected to go into the nitty-gritty of Kubernetes. That is for DevOps people and DevOps guys. But I think in the context of MLOps, knowing the basics of the resources and then being able to, I'm sure you guys must have worked with what they call it now, Kubeflow, which is the machine learning flavor for Kubernetes for running workflows. To be able to use all those resources very well, the basic things that you need to understand is what I have tried to explain to you. Although there's still the concept of security, like I said, which is also still important, namespaces, secrets, ingress and egress rules, and all of those things. But like, there's no time to talk about all of those right now. One thing that I'm just going to mention before we go is that, let me come here. Deployment with probes, you can come and experiment with this. And what it does is that it will not start, or it will not make the container that you are trying to deploy in the deployment available until it has checked something. So for example, now, since we know that we are creating a microservice with a small server for serving a prediction application, we want to be sure that that particular service is running before we make it open to clients. So you do a readiness probe, and the type of readiness probe is TCP socket. You want to test the port 8000, and the initial delay seconds here is saying that, okay, before you test it, give this thing 6 seconds to try to start. After 6 seconds, probe that port and see if it is available. So if this comes back with a request message of 200 to, I think, is it 300? I'm not sure. All those positive request messages, then it will say that, okay, this particular container is ready for usage. But if it doesn't work, which means that the server is not working well in our container, it will not start this container and open it for use. It will tell you that there's an error. So that's what this readiness probe is for. Readiness probe is just to make, as the name implies, it's trying to make sure that that particular service is still in operation. So from time to time, it's going to just probe that after having started it and we have let the client have access to it. Readiness probe will be making sure that that particular service is still operational. And if it fails, then we can attach some kind of alert with this liveliness probe to trigger some other things that are a little bit more complicated than what we are dealing with here. I'm just trying to explain some other things that I had prepared for today, and I think that's basically it. Yeah, apart from rollouts that we did not touch at all. So yeah, I hope that was interesting to us to some extent, and
Yes,
we
very
are
much.
curious. We are curious enough
Could
to go
you,
and find out more. You said?
yes, could you please push your code to the repo so that I put it?
I should push my what?
Could you push your codes to the repository?
Yeah, it is there. It is there. If you come here, you can see configuration files, and you will see all of those configuration files that I was talking about, with probes, with volume, with config map, the config map that you use, with volume you use this percent volume claim and this volume. Note that you need to make available the volume and the percent volume claim first before you will deploy an application that will be using that volume. And then this Kubernetes you can just ignore. This is something that I worked on a long time ago, but like these other ones, you can play around with them. I think I made some few changes again that I would like to push, especially for the sidecar that is not here yet. But I'm having issues with my GitHub on my VM. But when I resolve that, I'm going to push that code here too, so that you guys can play with it. So yeah.
Thank you very much.
You're welcome. So
It
yes,
was a very
Christian,
good session.
I'm glad that you were able to learn one or two things. That's why I'm here. I'm surprised that a lot more of you did not come for the Zoom, so that they can ask questions and I can answer them. But that's all right. I hope they get what they can from the video on YouTube.
Yes, if I get some question, I will ask them in the Slack channel.
On Slack?
Yes, if I have a question,
All
I
right,
will
no
ask
problem.
them on the Slack channel.
I guess anybody can answer it actually, but if nobody's answering it, you can get forwarded to me and I can give replies.
Okay, thank you.
Yeah. So thank you, Christian.
Yeah, I can hear you, Danny. Thank you very much. That was an interesting session. Since there's no other question, even on YouTube, I guess they got a good understanding of all the concepts. All right, thank you everybody for joining. See you next time. Have a lovely weekend.